and libraries, and then finally some code examples, those things that might help you doing your own stuff, some common errors, pitfalls that people usually do, and I'll help you avoid them. Programmer since 1991, working in groups Fit and Lievestura, which is a MSX group. And during that time I've done stuff for rather many platforms, starting from MS-DOS and then moving on to Linux and OS X and some others as well. Rather freaky stuff as IRIX and GamePark 32. And then some short excursions to MSX and Linux, MSX and Falcon as well. And in addition to demo programming, I've done some real work on these as well. Even multi-platform porting. You can notice that there's some Windows in the list. And I tried to keep that way. I asked that in work interviews. Okay, but this is how it goes. In the late 80s and early 90s, people wrote demos mostly for the specific hardware. And games instead, they were very multi-platform. Game developers wanted to address a large audience, so they made their games multi-platform. And you can see this same thing happening now in the games consoles. A popular title is usually released on 3 consoles. And okay, in the early 90s, demos were mainly very hardware specific. But then things started to change. And here are 3 examples of multi-platform productions. And the first one that I found was Helizer by Q Members Group, and then Hard Rocks by Skull, to be member of Bomb. And I guess some of you have seen this Hard Rocks thing. It was for MS-DOS and Linux at least. And then this Mega Demo 4.2, which was originally for Amiga, but then it was the first mega multi-platform demo. It's available for at least 10 different platforms. At least. Okay, let's move on. Now that we don't deal that much with hardware anymore, it's not a freak thing. It's not uncommon to port your demos. And I've gathered here 5 well-known multi-platform productions. I'm sure you have seen most of them. VIP2 Invitation, nice production. DOS 2, that was released in assembly years back. State of Mind by Bomb, and the thing is coded by Skull, the same guy that did the Hard Rocks thing. The winner of last year's demo combo, Obsolete, was available for Windows and Linux, and then Variform by Coolers or Kevlers or whatever, that was first made for Windows, but now it's available for OS X as well. I tried to ask them for the source, so I brought it to Linux, but they didn't give it. It's probably full of dark trade secrets that they can't hand out. And then a list of some groups that have done multi-platform stuff. And, well, I suppose you recognize most of the names. I had to put myself in there, of course, now that I got the chance. One group that's missing is Spent, that I left out by mistake. But they have done stuff for Windows and Mac OS X. Okay, what happened in the mid-90s? why did the things change? First of all, demos started to use mainly frame buffer effects. On Amiga, you had those chunky to planar converters, ham8 modes, and copper chunky modes, and crazy stuff like that. And of course, you use the Pro Tracker replay, for example, the Pro Replay or the Player by Reunanen here. And on the PC, you did mostly the same kind of stuff. This chunky mode, 13 ugly mode stuff, or then VESA 2 linear frame buffer stuff, and then used module player such as Midas, which is also partly written by Reunanen here. Thank him for all the module players. And well, if you compare these two, what's the difference? You have a chunky frame buffer and you have a module player. And that's the same thing on Amiga and PC, which were the dominant platforms back then. So it was quite easy to port stuff. And so many people did when they moved from Amiga to PC. They abandoned their beloved machine. Those traitors, they easily ported their Amiga stuff onto PC. Okay, I shouldn't be talking about traitors here. I might be considered the worst traitor of all, since I've abandoned every platform. Okay, these days, people use mostly OpenGL or DirectX, have those frame buffer things going on. And then we have module, MP3 or OGG replayers, and then we need a timer. But the focus has switched from hardware banging to design and algorithms, and those are very universal things. They are not hardware dependent. And instead of assembler, we use those higher level languages such as C and C++, which are portable by nature. There are some differences left if you write some exotic hardware, some handhelds or PDAs, other small systems. They might be different, but the high-end machines these days, like Linux PC, Windows PCs, and OS 10, they are pretty much the same. They all have the same programming interfaces. Okay, now I'm trying to do some propaganda here. Why should you port your stuff? Well, first of all, you might learn a lot. You might get to know a new, nice platform that you can probably use in the future. And okay, this is my personal opinion. If you port your code, it tends to be cleaner. And that's because you have to give some thought. But occasionally, and usually when you write some demo code, you just hack it in, and there it is. But if you design it to be portable, then you have to give some thought to it, which makes it a little cleaner. Larger audience, okay, might not be such a big point here. But the thing about the alternative scenes for those exotic hardware platforms, the nice thing is that they really have a nice communities. That the people there are very happy when they get new products for their old or exotic systems, and you might get very nice feedback and a lot of visibility in the alternative scenes, which is very different to the Windows scene, where you have to be really on the top to be known. And to me, it's at least it's rewarding to see your stuff running. The thing that you have coded on the PC, for example, when you get to see it on a PDA, it's a very nice experience, or some exotic games console or something. It's rewarding. You feel like you've achieved something. And at the end of the day, once you learn this portable programming style, it's not a big thing to port your stuff. For example, the demos that I've written, we usually get at least 4 versions: Linux, OS X, IRIX, and Windows, the same day that the thing is finished. So it's not much extra work there. But there is some overhead, of course, involved. Okay, then some cons of porting, why you shouldn't do it. If you're going to use very low-end, some low-end device, say Amiga 500 or a handheld, you probably have to use a lot of hardware tricks, and they are not available on other hardware. And then, of course, the OS-specific libraries are missing as well, which can make size optimization quite tricky. And larger thing is that if you write to a great variety of platforms, starting from a PDA or low-end Amiga, for example, you can't really put too much stuff in there. Then the high-end PC will run the thing very easily, but it won't look very impressive on the better hardware. Okay, then some strategies, how you could port your own demo. This is something I did in the past. I wrote my own wrapper libraries, and it was quite a nice experience. I learned a lot about the underlying operating system, but and got really small libraries, wrappers for myself. And then, on the other hand, it was very error-prone. Those of you who have written software for, say, the X Windows system know that it's a hell to get working right. So if someone else has done that thing for you, it's always nicer. You don't have to deal with hardware and software-specific bugs. So if you use those common libraries, I'll tell you a bit more about them later. It's going to be easy. And on the other hand, they tend to be quite big. And being an open source friend myself, I'd like to at least give a point of view on this open source thing. If you release the source code for your demo, then it's possible that somebody else might do the porting work for you, such as my friend Piru here, who has ported our demos to Amiga, Amiga-like Morph OS system. And so that's no extra effort for you. And this is something I've noticed. If you keep the source code to yourself, then you always experience some hardware crash, mostly hard drive crash, and then you lose all your source. But if you distribute it, then it's somewhere. Somebody has the source, and you can find it later. When I talk to people about this, they always are pretty skeptic about their own code. They say it's messy, it's bad code, nobody wants to see it that kind of code, and nobody has any use for it. But that's the same with all demo code. You shouldn't be too critical to yourself. For example, I've published at least 10 of our latest demos with the source code, and it couldn't be it's probably not very good code, but I've lost the self-criticism here, so I just let it go. Okay, this might be a bit problematic if there are some Java lovers around. I must say about Java that it's very portable by nature, which is of course a good thing. You don't have to see any extra trouble to make it portable. But the thing is that there are bad implementations, and on some platforms Java is really slow, so it might not be the best alternative for mega multi-platform demos. And for very old or low-end devices, it's not available either. Okay, then to the tools that I've used, C and C++. They are portable in theory. They were written to be portable, but at least C++ might be very bad on low-end devices, since old compilers might not have C++ at all, or then if you're doing cross-compilation, there might not be C++. And the standard has evolved so much during the years that old compilers might just puke the source that you give to them. Okay, personally I always use C. It has the best availability. You take any 8-bit embedded device, you almost always have a C compiler for it. But of course it's a low-level programming tool, and so it might not be always nice to write pure C. Pascal. It's too bad that people who wrote Turbo Pascal code in the early 90s abandoned their language of choice, and then they went for Whatcom C or something. Pascal isn't that bad. It's very available, and they are quite good compilers for Pascal. I saw a demo this week that was written in Pascal, and it was available for at least 4 platforms. Okay, and then interpreted languages, those we usually don't use because they are too slow. They could be used for scripting, but not a whole thing. Okay, then a word about the programming interfaces. For 2D graphics, there's SDL, which is very available, and then there's PTC. I don't think people use PTC that much anymore, but it used to be quite popular. And for 3D graphics, obviously, you have to use OpenGL to keep it portable. But the problem with OpenGL is, of course, that it's not as feature-rich as DirectX. If you want to have the latest shaders, then OpenGL might not be for you. And the OpenGL needs these front-end libraries as well. For those, people tend to use SDL or GLUT. Others exist, but these are known to work. And for sound, you can use SDL. So as you can see, SDL is available on all the bullets. If you keep to SDL, then you can do all the necessary things for a demo, at least. Maybe not for a fully fledged game, or okay, they've written games with SDL, but say an accounting software, you can't do that on SDL. For sound, port audio is also portable, and then those module and MPEG players. So there are quite nice alternatives, multi-platform libraries available. Okay, then a word about programming tools. Personally, I use GNU C compiler a lot. Even our Windows ports are compiled with GCC. If you install Cygwin or MingW, then you can have the full GNU environment for your Windows, which makes it very easy to port Unix stuff there. And it's of course free. You don't have to use any pirate software. Not that anyone would do it anyway, but it's a free alternative at least. And it's also available you can do cross development on GCC. Those of you who have done some stuff for handhelds or consoles, for example, have possibly used the GCC for cross compiling. Okay, I won't go too deep to make files, but I'll say this: they make your life easier when porting. If you write a good make file, you can very easily take it to another platform and compile the thing very easily and tweak the compiler flags perhaps and some library paths also, but basically it's quite easy. If you have a cleanly written make file, it's quite easy to port the thing. Okay, if you have never seen a make file, here's one for you. Basically, you give the dependencies of the files and compiler flags and the command line tools. Okay. So much for the propaganda. Now we'll go to practical code examples that might be actually useful for you. These are common pitfalls and things that I've run across, and those errors that people tend to do over and over when they start to do portable stuff. So you can probably learn something and then avoid those common mistakes when you're doing your own stuff. A full list of these is available at that address. Some of the big names of demo scene gave me comments about the list, so it's probably up to date and somewhat error-free. Okay, first, this is very trivial, but in practice you have to do this. You have to encapsulate your platform-specific code. It always has to go to modules and subroutines so that you don't have to search and replace the platform-specific calls. You just rewrite the library or then the specific subroutine. Okay, then to timing. If you intend to use CPU loops, then you probably have something to learn about programming, but I'll warn you about them anyway. Don't use them. If people have a faster or slower machine than yours, then the CPU timing loops will break. And I also have a bit bad experience with those high-resolution alarm timers. Even though on many systems they work well, but if you want to keep the source portable, you shouldn't rely on them because, for example, on Linux or other Unix systems, when there's system load, the timers, these alarm timers, they start to slow down. And they also have a different resolution in different systems. So usually we rely on just one timer. And SDL has this SDL get ticks, which gives you a timer of 1 millisecond. And that's pretty much enough for demos, at least. And in POSIX, there's get time of day, which gives you microseconds in theory, but not in practice. But it's better than get ticks. Okay, this is something that people probably predicted already. I'll talk a bit about Endian clean and Endian dirty programs. Some common systems that are little Endian are, of course, Intel, then ARM, Alpha, SH4, which can be found in Dreamcast, and Zilog 80. And then there are big Endian systems, PowerPC, MIPS, Spark, 64K, and 6809. And what does it mean if a system is a big Endian system or a little Endian system? Here we have a long word consisting of those numbers, and in memory, when it's stored in the computer memory, little Endian systems store the bytes in a different order than big Endian systems. You can always debate which is better, but we won't go into that. This doesn't affect bytes, of course, but if you use 16-bit or larger entities, then this might affect you as well. And this is something that I found useful. For example, here we read 4 bytes from the disk, and they are supposed to construct a long word. But if we do it with fread, then it's not Endian clean, because the thing is stored in wrong order in the memory. But if we read 1 byte at a time and then shift it to the correct position, then it's Endian clean. Usually this goes for 32-bit frame buffers as well, but not always. So you can't, if you want to make it absolutely sure, you can make the RGB values by shifting. Usually this holds, but not always. For example, SDL has this SDL map RGB, which gives you the correct byte order. But for OpenGL, if it says RGBA, then it's RGBA in the memory as well. So OpenGL tends to be quite Endian clean by nature. The Endian things are not that complicated once you know what are the problematic places in your code. After a while, you won't even notice it, and you'll probably start writing Endian clean code yourself. You don't have to take care of that too much. Then a little about data types. There are quite many tricks and things that can go wrong with data types. For example, if you use char to hold a byte, it can be signed or unsigned, and that's up to the compiler to decide. I don't think C standard says anything to this. So if you want to make sure that you have the correct signedness, then you should use signed char or unsigned char. And this is a bit puristic thing. C standard doesn't actually provide you with 32-bit integer. It's long, and for example, in MS-DOS, some compilers had only 16-bit int default size, but mostly it's 32 bits these days. And in 64-bit architectures, you can't fit a pointer into a long, since long might be 32 bits and the pointer 64. So you don't really need to do this. Do your pointer arithmetic some other way. And then the alignment thing. If you write structures, then you can't really count the size of individual elements there and sum them up to get the full size of the structure. You have to use size of here, because on many platforms, for example, single byte values are padded so that they might take actually 4 bytes there. And then you should also reference the structure members by their names, not try to, for example, read from a disk a large chunk that is supposed to go to the structure. And other alignment problems that you might face. On many systems, 16 or 32-bit values have to be aligned. If you don't have them aligned, you might get an exception, or you might get wrong results, or some other odd behavior. But it's slow anyway, so you should avoid it, even on those systems where it works. And this is for mostly Unix people. If you want to have a large local array, here we have a 4 megabyte or 2 megabyte array. Most systems can't handle this. Unix systems, they grow the stack and it's okay for them, but not all systems do this. So if you put static int there, then it should be okay. This is something that I've at least noticed. Then it's not allocated on the stack, but on the heap instead, and there's more space there. Okay, then some miscellaneous tips. This is something that might cause hard to find bugs. If you assume that the local variables are 0, then you might get very oddly working bugs. And I've done this a couple of times, and it was really hard to trace where the problem actually was. So you'll be safe if you initialize the local variables always when you use them. And in MS-DOS or Amiga, you could do this first alternative. You could define a string constant and then change it later. But on Unix systems and even Windows, if you try to change the string constant later, your program will probably crash, because the strings are placed in read-only memory. So the latter alternative works, whereas the first doesn't. And this is something that requires a little patience and effort. Whenever you use a function, you should always also include the header for it. It might run on your system, and it seems to be fine, but when trying it on another system, for example, it's very likely that you get compiler errors. They might be easy to fix when you add the include files there, but sometimes the bugs go unnoticed. You haven't included the thing. Okay, the compiler might assume what are the default parameter types, and usually it's integer. And if it's something else that you're giving the function, then you will get some odd behavior. So if the declaration does not exist, the compiler might just assume something, and it might be wrong. And typically this is the case for math age. So whenever you use floats, you should include this math header. Then some other miscellaneous tricks. For example, the main function, you're supposed to exit with an exit value that tells the operating system that it was a clean exit. And if you're very puristic, you could use this exit success, which can be found in std lib point h, or just use 0. That's clean exit on many or all systems, because that's the Unix way, and C comes from Unix. If you don't do this, you get a warning on OS 10, for example. And when you're running this stuff from Unix, if you're running it from a script or a make file, they might think that there was some problem, and they might stop executing the thing after your software exits. Okay, this is just little something. You might want to flush your output when you're doing those debug prints. Most systems flush the std out when you put a line feed there. Or then you could use, if you want to be absolutely sure, you can use this flush, or in C++ this flush keyword. And that makes sure the thing is printed on screen. Because if your program crashes somewhere between the error prints, you might not see the actual printout, although the software did get to the point where it wrote it. But if you didn't flush the output, it's not displayed on screen. And then something about paths. Even MS-DOS compilers, if you use the slash, they converted it to backslash automatically. So use that as a path separator, even in Windows. But a better way is presented here. At the bottom of the screen, you could use defines to prefix those file loads. So you can always then, you can change the define so that the thing is loaded from a correct place on different systems. This is something I've noticed, at least on Game Park and Dreamcast. Generally, they don't like the relative file paths. So you have to load the stuff from absolute path. And then with the prefix trick, you could do this very easily. And you don't have to change the paths for every single file. Just change the define. Okay, the last page. A bit about source code formatting. Nothing fancy, but it could make life easier when you're doing multi-platform stuff. For example, a lot of code that comes from Visual Studio has a tab width of 4, but it's in the file it's still tabs. So if you load that kind of file in Unix, you get a different indentation, because usually tab is 4 characters. If you use that 4 character tab, then you can save the source with tabs as spaces, and that keeps the source readable on other systems as well, and editors, even on the same platform. When porting, a little intro from Windows, I ran into a problem like this. The guy had used different keys in different files, and then I had to go one by one, each include and each file I had to change it so that the case was correct. So if you want to use case, if you don't want to use only lowercase, for example, just be consistent and look at the file name and then write the same thing to the include statement. That's a very easy thing to do. You won't notice this on MS-DOS or Windows, but on other systems, the case does matter. Okay, just a couple of small details. Although the source might compile okay if you have used your native umlaut characters, then when you load it up on another system, it might look at least very funny in the editor, although it's okay if you compile it. And the same goes for line feeds as well. More in practice, for example, GNU C compiler, it eats all the possible line feed combinations. But if you want to be absolutely sure, just use the single line feed character that's used, for example, in Unix or Amiga. Every compiler that I've seen this far accepts those line feeds, so you will save some trouble there, probably. Okay, that's it, and thank you very much for your attention. Now I think we have time for a couple of questions, if any. Okay, it's very nice that I answered all of them. Could you rephrase that?
Sorry, okay, so you said that the major frameworks that were used were all Java to begin with, but not really, and then SDL. Were there any other major ones?
Well, these are pretty much my own preferences. Okay, the question was about the platforms and the libraries and the tools that were used. And these are pretty much my own favorites, something that I've noticed that work pretty well. So my personal suggestion would be to use pure C and SDL. That's a good combination. That's been good for me. And C++, that might be okay too if you write for high-end systems. Did that answer your question? Thank you. Okay, another? That's a good question. So what do we do if we want to have portable code and still want to make, say, a 4K or 64K production? And this is what I have done. Because SDL is a big bunch, it's already bigger than a 64K intro should be. Then I've taken this approach, which some might consider lame, and I've even heard it said to me. But the thing is that only on Linux, the thing is, because on Linux you can assume that people have SDL installed. Then I've done this, that 4K or 64K things. Then I've used SDL as a dynamically loaded library. And then the other platforms have the SDL library in the package, and they are not anywhere near 4K or 64K. But this might be easier if you write your own wrappers. Then you can make them very compact and small, and yet portable. But this is a bit problematic question. Some people think that you're not allowed to use SDL, for example, in 4K intros and consider it lame, so you have to take that to account if you want to avoid flame wars. This was a big question, and there was a lot of debate in Poet.net about our demo, our 4K intro, Yellow Rose of Texas, and some people called it a 600K intro or something because we included the DLL in the Windows version. But this is a bit of a matter of taste. But this is what I have done. Could you repeat that, please? Shader programming. Okay, that's a bit of a problem. I haven't done that myself to this date, but the thing is that shaders are not at the moment very portable. When we get full OpenGL 2, it's been promised for at least 3 years, and now we have some crappy implementations lying around. But the thing is that shaders are not at the moment very well portable, and that's a big problem of them. Once we get OpenGL 2 and GL's shading language starts to be common, then the problem is solved. But at the moment, I'm afraid not. That's a good point as well. The shaders are evolving so fast that it's hard to keep them backwards portable. I don't have any good. It's better that I don't speak too much about shaders since I haven't programmed them myself. So It just might be a bit of guessing, but it's a good point that you made that we might lose the backwards compatibility with them as well, which does not happen with, say, frame buffer code or OpenGL. We have had OpenGL lying around for 13 years, and it has changed very little during that time. Other questions?